Group 10 projects: Industry, Construction, Company, Ellisdon Corporation. Ellisdon Corporation is a design and build firm that offers a range of services from construction, engineering, project management, and general contracting. They are one of the industry leaders in construction in Canada, and their headquarters is at Mississauga. They commenced operations about 70 years ago, and today they complete about $5 billion worth of construction volume annually. Their core strengths lie in design build excellence, infrastructure and technological optimization. They also pioneer capital for their P3 investments, innovation through their construction services, and also data and digital engineering. Now, all these their competencies, they seamlessly integrate design, construction, technology, investment, innovation. All of this is to shape the future of the industry. Ellisdon Corporation's projects spans diverse sectors from commercial, institutional, industrial, showing their versatility in construction. Their portfolio shows very iconic landmarks from airports, colleges, pavilions, bridges, showing their expertise in delivering very complex and impactful structures.
Imagine a world where every bridge is a living, breathing entity, constantly communicating its health in real time. We don't have to imagine. The tragic collapse of the Quebec de la Concorde overpass in 2006 reminds us why real-time structural health monitoring is not just a luxury but a necessity. Today, we have the technology to ensure our construction projects speak to us, warning us of potential issues before tragedy strikes. It is time to embrace real-time monitoring, turning our bridges into intelligent structures that prioritize safety. In 2006, tragedy struck the Boulevard de la Concorde in Quebec. The bridge, built in 1970 with a planned lifespan of 70 years, collapsed, claiming lives and vehicles after only 36 years. What if we had the right technology then? A state-of-the-art structural health monitoring system capable of detecting underlying issues, warning us in real time and averting disasters. Today, as we reflect on the De La Concorde incident, we aim to ensure that every project tells a story of health daily, preventing history from repeating itself. The power of real-time monitoring is not just about technology, it's about saving lives and securing our future. Technology-enabled monitoring systems offer real-time insights, detecting anomalies as they happen, while non-technology-based solutions rely on inspection. Then there are early warnings that can capacity that can be derived through the use of technology-based solutions. They can alert project managers and engineers when structural issues emerge. And for the third one is data analysis. They facilitate data analysis for predictive maintenance, enable identification of risk before they escalate, while non-technology approaches typically lack the capacity for advanced data analysis.
To the support of operational challenge, let's imagine a construction world where being an open, responsible and saving money are the top priorities. After the Laval overpass incidents, we have started using super smart technologies like fiber optic sensing, wireless sensor network to keep constant eye how our constructions are doing. This means we are completely clear about how well our construction are holding up, and we are making sure we are stick on safety rules. By using these new ideas, we are not just making on building more reliable, but we are also saving a lot of money in long term. It's like promising a creating safer, better way of a building things, where each structure shows how serious we are about being open, responsible and careful with resources. It's not just about safety, but it's about saving money too. By taking care of these things early on, we can reduce repair costs and make our solution more affordable.
The first approach is fiber optic sensing technology. By integrating optical fibers within a structure during construction or after, we can facilitate continuous monitoring of key parameters like strain, temperature, vibrations, and other critical structural elements. Here is how it works. The embedded optical fibers serve as sensors, and any change in strain, temperature, or structural elements can cause variations in the way light travels through the fibers, and then this can be analyzed. The collected data is then transmitted wirelessly from the sensors to a centralized gateway or hub for data aggregation and transmission. A data analysis software interprets the collected data, transforming it into actionable insights for informed decision making and preemptive issue resolution as it relates to the construction project.
The second technology is acoustic emission, which listens to the sound produced by materials when they are deformed. It relies on very sensitive sensors that detect the acoustic waves or sounds that are emitted by materials when they undergo stress. Special sensors are used that are placed in or around the structure to detect any acoustic emissions, which are then further analyzed. It's especially relevant to construction industries due to its capacity to monitor structural integrity and can also help them to preemptively detect any potential issues, ensure timely maintenance, long-term safety, and also the durability of the structures. Overview of the cost involved for this technology is the purchase for the sensors, data analysis of it, and maybe maintenance and calibration going forward.
Another technology that we have identified is a wireless sensor network, which is a smart way to keep an eye on the structure. We establish wireless sensors around the construction sites, checking important things like strain, temperature, humidity, and vibration all the time. And these sensors stock a central system without any wires, and this system checks and understands the data too. It is smooth and quick process, giving us the scope of how well construction is holding up. In regarding the cost, at the start we have to buy these sensors and the main connection units. After that, there are regular checkups, and sometimes we need new batteries too. Also, we need good software to make sense of all the information. In short, wireless sensor network is a money-wise, real-time way to watch over structures, and it will make construction more safer.
To refine all our options and make a recommendation, we thoroughly analyze each solution. For fiber optic solution, even though it offers extensive monitoring coverage and real-time data, its setup costs and its maintenance costs were too high. For the acoustic emission solution, it's cost effective with real-time monitoring. However, it's limited to only acoustic events and it has high false alarm potential. So we chose as the best option the wireless sensor network solution because it balances cost and functionality and it provides wireless deployment and also has versatility in monitoring and is suitable for varying structures.
Let's talk about the implementation plan. As a pre-implementation, we will do the project kickoff, site assessments, and vendor engagement within week 1 to 5, and then we will start the hardware development within week 6 to 10, including sensor development, gateway installation. After that, we will do the software configuration, testing, and optimization within week 11 to 12, and we will plan to do the post-implementation finally within week 13 to 16, including training, documentation, and final adjustments. This implementation plan provides a structural timeline for developing the wireless sensor network solution on the level overpass. Regular monitoring, maintenance, and performance evaluation will ensure long-term effectiveness of this system.
For the wireless sensors network, the assumptions we still assume that the bridge length of 500 meters, and then the number of sensors is 50 at $345 per sensor. Now we have the sensor cost, the installation cost, the software cost, which is a one-time flat fee, and the maintenance cost. So the implementation cost is addition of all the constituent costs. Now, to determine our return on investment for the wireless sensory network, we look at the formula for the calculation of return on investment to be net benefit minus the cost implementation divided by cost implementation multiplied by 100. Now, for us, what is important here is the net benefit. The net benefit is the opportunity cost if that project fails. So for an overpass, for instance, if the overpass collapses, then it has to be reconstructed. What are the things that will go into the reconstruction of the overpass? You are looking at engineering and design fees. You are looking at labor costs. Engineering and design fees typically 10% thereabout of project costs. Labor costs are 20%, and the contingencies are 10%. Then the material costs are 40%. So all that goes into the cost of reconstruction, which is the net benefit. So if you remove the cost of benefit, which I already discussed in the videos earlier on, then you are able to determine what your return on investment on the project is.
When talking about the benefits of investing in wireless sensor networking for structural health monitoring, it's not just a commitment to safety, it's a smart business move too. Because with WSN, they are not only reducing upfront cost but also ensuring long-term savings too. Imagine the efficiency of wireless development, real-time monitoring of key parameters, and also flexibility to adapt and expand their network as needed. If it's not just an investment in infrastructures, it's an investment in the future where every construction project stand a testament of cost effectiveness, reliability, and the seamless integration of cutting edge technology too. So WSN is not just monitoring, it's all about business strategy of success too.